Hello, welcome back to another teacher tip video from the Center for Inquiry-Based Learning. Today we're going to be looking at our 5th grade materials unit, and the first activity we're going to jump into is called conservation of matter. It is a demonstration, and it's something that you're going to be doing the hands-on as the teacher, but instead of it being a passive demonstration, it's going to be active in that we're going to be asking students to think about what's going to happen, make predictions, analyze what happened, and of course using our inquiry style, we're going to work through these two parts of this activity, and the goal is to have students start to develop an understanding of the conservation of matter. Instead of showing them and telling them, we're hoping that they're going to build that together as a class. So let's get started. First thing you're going to notice is you're going to need to get your scale out. One thing about the scale, it's real sensitive. Sometimes when you put something on there, it might go up and down 1/10 of a gram. So whenever I work with my students, I always say, we always get kind of a plus minus of 1/10 of a gram, just because those things are going to be bouncing around. Also, for this activity, you'll need some sugar cubes, some water, some index cards, and you'll have to get your own bottle. This is just a regular 16-ounce bottle, water bottle that I got and rinsed out. And make sure you have the cap as well. So we're going to get started. And the first part of the activity, this is part one, called Where's the Sugar? First thing we do is we get our scale, turn it on, and zero it. I think that's correct, yep. Right? All right, go ahead and put a little bit of water in our bottle. Place it on the scale. Put the cap on. Oops. The cap on it. All right. And we're going to record the mass of the bottle, the water, and the cap. What do you got there, Rachel?
64.9.
All right. Next thing we do is we go ahead and grab 2 sugar cubes from our kit, place it right next to the scale, and now we're going to record the mass of the bottle, the water, the cap, and
72.1.
0.1. All right. Now what we do is simply open the bottle, drop the sugar cubes in, and put the top on, set it down. And here, as a teacher, you get to practice your acting skills, because you get to go, oh, whoops, I forgot to get the mass of the sugar cubes. And so give the kids a quick little opportunity for a math extension to have them figure out the mass of the sugar cubes using that information, because obviously we can't measure the mass of the sugar cubes anymore. So just a real quick opportunity to do a math extension. But the more important thing here is, go ahead, kids look at this for a while. It doesn't take a little too long. If you can you see that, Rachel?
Mm-hmm. Yeah, it got cloudy, okay. And then
yeah,
now
it's pretty clear that the sugar cubes you can't see anymore. So you ask the kids, what do you observe? What do you notice? And oftentimes they'll say, sugar cubes disappeared. Fair. What does that mean? And where did they go? So asking kids to share what they think, that's the goal of these activities, is to get them to start thinking about what could have happened. It's not about being right or wrong, it's about just speculating and wondering right now, because we'll figure out what happened, of course, at the end. So at this point, getting ready to put it back on the scale, but not quite yet. What you want to have students do is look at our picture with 3 different people looking at this same bottle, and they have to pick which one they agree with. Do they agree with A, B, or C? You also hand out an index card to each kid, and each student, and they will put down the letter that they agree with and why they think that that person is right. So everyone made their speculations, made their predictions, and then we go ahead and place it on the scale. Oh, it's minus nothing. What do you got?
72.1.
Ah, 72.1. Now, just remember in your class, it might be 72.0, or it might go up or down 1/10 of a gram, but it'll be right close. It'll be right near the
It just went up 10.
Yeah, exactly. So right now, we look at this and we ask the students, okay, so going back to the bubbles, the pictures, which one was, correct, and start to think about what's happening here. So at this point in the activity, we ask students to write a rule. Write a rule to explain what's happening here, why the mass stayed the same, even though clearly it looks like the sugar cubes dissolved. So that's the opportunity for them to begin to formulate an understanding of conservation of matter. At this point, we also explain the conservation of matter, show the definition, and have them compare it to what the students have written. So now they feel like they got a little bit of an understanding of it. We're going to go to part 2, which is called bubbles, and we're going to challenge that conservation of matter definition a little bit, just to make sure that we're making sure that they're understanding it. So part 2 is coming up. Okay, welcome back. This is part 2 of our conservation of matter activity from materials unit, and this one is called bubbles. And last activity we had them start to formulate their idea, their understanding of conservation of mass. We start this activity with them reminding us of what they think the conservation of mass is, and then we go ahead and introduce our new demonstration. For this one, same bottle, some water. You're gonna have to have a 9-ounce cup of water. Instead of sugar cubes, we have Alka-Seltzer tablets, which are in the kit, and you're gonna need to have your same digital scale. All right, so for this activity, we're going to, once again, add some water to the bottle. This is a good little tip here. It's wise to dry off the mouth of the bottle because you're gonna be placing an Alka-Seltzer tablet in there in a second. So right now we go ahead and get the mass of the bottle and the water, and we're going to write that down.
71.3.
All right, and again, you still have that plus minus 1 gram idea. So we take an Alka-Seltzer tablet, effervescent tablet, and break it in half, place it on the scale, and now we're going to record the mass of the bottle, the water, and the tablet.
So 74.6.
74.6. All right, so in a second we're going to put those two together, but 5th graders might not be sure what an Alka-Seltzer tablet or an effervescent tablet does. So tell the students that watch what happens when an Alka-Seltzer tablet and water come together so they can see what the result is. And of course, students will report tablet looks dissolving, gases being made, bubbles, so forth. So based on that information, based on what they know about the conservation of matter, when we put the tablets in the water, students should predict what they think is going to happen to the mass. And ask students to record that and share their predictions. At that point, we're still at 74.5 now. Okay, that's fine, plus minus a gram, 1/10 of a gram. Go ahead and, this takes a little bit of practice, but place them into the lip there, and just to see if you can still get it to show the same mass, 74.5, 74.6.
Yep.
All right, still the same all together. And this time you let it sit for a minute or so, and if you have a document camera, you can have the kids be looking at the dial. So right now it's 74.4, 74.3, 2.
This is really good even if you're teaching virtually too, because this is a great way, like Todd said, to use your document camera so that the students can see it on their laptops or in the back of the classroom.
Right. It is one that can be done anywhere. The key thing is getting those students to make some predictions and do some thinking. So, what do we notice that happened first of all to the effervescent tablet? Like the sugar cube, dissolved, disappeared. But what happened to the mass? You're supposed to take it and swirl around a little bit, finish the reaction, get some of the air out. And what is the mass now?
74.
74. So, was 74.6 and now it's 74. What happened? This is where we want students to think, wait a minute, based on that conservation of matter that we did last time, this doesn't seem to follow that rule. So ask kids to speculate and think about, well, what happened here? Why did this one not follow the rule? Hopefully at some point someone might say, hey, we don't have a cap. Maybe that had something to do with it. We don't have a closed system. If they do, they do. If they don't, they don't. But that's something that we hope that they would speculate on. So what we're going to do is say, we're going to do this exact same experiment again, but this time we're going to keep the cap on, and we'll challenge that prediction. All right, so we're ready for the second part of the bubbles activity. Cleaned and rinsed out my bottle. Got my Alka-Seltzer tablet there broken in half. So we'll be doing the same experiment that we did the first time. The only thing that's different is going to be, obviously we're going to add a cap and we're going to close it. So add some water to our bottle. Doesn't really matter how much, a couple ounces, a little bit of dry inside in case some water's in there. Oh, what am I doing? Bottle, water, cap. Make sure this unit is tailored.
Yep.
We're at 0. There's the water and effervescent tablet.
$58.1.
58.1. Okay. Remember, we give a plus minus of a tenth or to a gram because these things tend to be really touchy and really sensitive. So that's our mass now. Go ahead and add the Alka-Seltzer to it. Screw on the cap tight. Screw the cap on tight. Place it back on, and it's going to take 30 seconds up to a minute for the Alka-Seltzer to dissolve. And hey, look at that. We're still... So the Alka-Seltzer looks like it's mostly dissolved there. Swirl, finish it up. And what's our mass? 58.1. It could very well be 58.0. It might even go up a tenth of a gram. So if that happens, it's not a big deal. But what's different about this one than the other one? And have students think about what is different. Of course, we have the cap. So this is an opportunity to introduce what a closed system and the difference between closed and an open system. So this one clearly, when we have the system closed, everything's contained, demonstrates a law of conservation of matter. So have the kids listen carefully as you take the lid off. They'll probably hear that whooshing sound. Ask students, where do they think that came from? And what do we think is going to happen when we place the bottle back on the scale now? We just took a closed system and turned it into an open system. Hopefully students speculate that lost some of the mass. So we'll put it back on. 56, is that what it says? Oh, I got the, I'm like, that's way too much. Gotta put the cap back on. All right, so we should be around 57 and a half or so.
Nice.
57.7, yeah. So about 4/10 of the mass, 4/10 of the gram is gone, and that's where students can start thinking about, well, the only thing that makes sense is the air left. So awesome opportunity. This is all about the conservation of matter. So you can see how we've taken one example and did 3 different things to get students to really build this conceptual understanding of what does it mean when we start talking about the conservation of matter.